Hello, I am David W. Parker. This is Programming Today I Learned 3D Math Series, episode 46. We're looking at matrix math yet again. Today we're going to be looking at how to compute the adjoint, as well as scaling in the cardinal axes, as well as scaling in arbitrary direction. As you will recall, we already figured out how to calculate the inverse. In this one we're going to calculate the adjoint, which is used to calculate the inverse. So we kind of glazed over this before, but this time we actually just make its own method. So everything you'll see here in the adjoint method is basically derived from the same inverse one. We just pulled it out and then we didn't compute the inverse portion. So this should all look very familiar to you. It's from episode 21, so we can look over there and see what that looks like. So we have an example here, and it is the transpose of the matrix of the cofactors. So here's each cofactor being calculated individually and then transposing it right here. So you can see the example. And we have the same exact output here because we put the same numbers in so that you could see what that adjoint looks like. So I implore you to just go ahead and look over this code and then rewatch episode 21 if you don't remember how to calculate this from scratch. And that's it for the adjoint. Next up, we have the scaling from cardinal axes as well as scaling from arbitrary direction. This is from episode 13, and so let's go ahead and take a look at what that looks like. So scaling in an cardinal direction is very, very simple. We're basically just setting the cardinal directions to the vector 3 that we're passing in and everything else to 0. So it's kind of very simplistic. So if we're scaling by cardinal directions with 3, 4, 3, we'll end up with the identity matrix times 3, 4, 3. So 3 is across 0, 0, 4, 0, 0, 0, 0, 3, 0. So that's pretty simple. Scaling in an arbitrary direction, on the other hand, is a little bit more complex, and that's also in episode 21. So you can see here that what we're going to do is we're going to have the unit vector parallel to the scalar k. We need to compute v prime. I'm not going to go over all of this from episode 21, so you can just jump back and rewatch that if you want to. But we derived this formula here in the end, and so putting this in the code, we end up with, this is our output, given this original matrix here, or excuse me, the identity matrix, scaled by this vector 3, 4, 3, with 2 being our scalar here. So you could see this is the same mathematics that is performed on episode 21, or 13 I should say, from the arbitrary direction scaling. So you can look at each of these and you can compare that to each of these lines here. And it's pretty simple, just translating it to code. So that's it for this episode. If you like what you saw, go ahead, subscribe, and give a like. Share this on social media if you will, and go to ProgrammingTIL.com and sign up for a newsletter. Thanks. Have a great one.